Hey, welcome to Rockstar Math. Today we are going to be going over the unit circle and basics and how to build it fast. First of all, the unit circle lies on the standard grid, the standard Cartesian plane. Ignore the point, it's just an image. So, on this graph, like you would do normally, like 7th and 8th grade, finding slope and finding rise over run. Instead of that, we're looking at circles. That's where your unit circle is. That's why on a unit circle that these 4 points are what they are. There's 1, 0, 0, 1, and then the same thing. -1, 0, -1, right? Those are your standard points. Those are these points it's lying inside. It's just super small. We're looking at a very blown up version of it. We're really zoomed in right now. So, because we are on the standard Cartesian plane, that's why these points are really weird. That's why they're not exact numbers, because these are irrational points. They're kind of just out wherever. We know that there are 3 points in every quadrant, right? And these are quadrants because, as we've talked about, we are on the standard Cartesian plane, where this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So same rules are going to apply. Like over here, a point will be positive x, positive y. Over here, that same point would be -x, positive y. Quadrant 3, both coordinates are negative. And in quadrant 4, you have positive x, negative y. Those same rules apply. That's why if anyone's ever told you that if you can complete the first quadrant, then you can complete them all, this is why. Is because there are only so many coordinates on the unit circle. They're all the same because it's a complete symmetrical circle. So the points are going to mirror on the other side, right? So these 3 points are going to be the same coordinates as these 3 points, the same numbers. They're just not going to be the same sign. So whatever's over here as xy will be -x, y over here. You see? So I think the thing that people struggle with the most are radians. Where are the radians coming from? What is a radian, right? A radian is a unit circle measure. So where are they coming from? So all the standard points on your unit circle in radians are reducible fractions. Right. There are 2 tiny points on every quadrant that are not explicitly listed because they're non-reducible. This first point, this is 1 pi over 12. So then this second point is 2 pi over 12, which reduces to pi over 6. This third point, 3 pi over 12, reduces to pi over 4. Same thing. 4 pi over 12 reduces to pi over 3. And then there's a secret 5 pi over 12. But you can't reduce that, so we just leave it out. And then you get to 6 pi over 12, which reduces to pi over 2. Same thing. 7 pi over 12, don't show. 8 pi over 12, reducing to 2 pi over 3. 9 pi over 12, reducing to 3 pi over 4. 10 pi over 12, reducing to 5 pi over 6. 11 pi over 12, can't reduce, we don't show it. Then that makes this point 12 pi over 12, reducing to pi, 1 pi. Right? And then you keep going around all the way until you get to 24 pi over 12, which is 2 pi. So then this is 0 and 2 pi. Okay, so now is probably the easiest part, the coordinates. How do we get our coordinates? The coordinates look messy, but they're really easy to find. Here's a little trick for you. My students use this once they've built up that familiarity after a while. So then I introduce them to this trick, and it makes it way easier to build it. So if you get a test or a quiz, immediately flip it over, find some blank space, and draw this unit circle. You can draw it in maybe 60 seconds. I'm going to test how fast I can draw it at the end. So, how do you find your points? What I do first, set up your parentheses, because this is going to go quick once you have your parentheses. Okay, put your commas. This is the part where it's going to be so easy that it's deceiving. We're just going to count to 3. We're going to go 1, 2, 3. And then 1, 2, 3. Every single fractional point on the unit circle is over 2. Put every single one of these over 2. And every number that is not 1 gets a square root. We're done. So, if you wanted to find the coordinate for 5 pi over 6, you would know, look at your over 6, it's going to be this, except that the coordinates in quadrant 2 are negative x, y. So we know that the coordinate for 5 pi over 6 has to be negative root 3 over 2, positive a half. And then you can do that every single time. You can fill in the second half of this unit circle. I'm going to take a brief break, clean this up, and I'm going to see how quickly I can actually draw this, and I'm going to time myself. I'm going to speed this up for you, but I'm not going to be speeding it up for me. So I'm going to set my stopwatch, and I'm going to see how fast I can do this. And go. It took me almost a minute and a half. Okay, it took me a minute and 22 seconds. So, I was a little under. My handwriting got a little messy at the end. That's alright though. I don't need to mirror the coordinates over, because like I said, they're all the same. Just switch the sign. Any number in radians over 4. So we got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. They are all different sign amalgamations of root 2 over 2. Okay, those are all going to be the same. Same thing as over 6. Over 6, over 6, over 6. They're all some amalgamation of signs, depending on the quadrant, of root 3 over 2 and a half. Lastly, just to reiterate, any over 3 is the same coordinate, just a different amalgamation of signs depending on where it is. Remember, location is the most important thing in trig. You need to know where you are in the unit circle. It's going to come up time and time again. Okay? So, thank you so much for watching. This is my first video ever, so if you have any questions or topics that you want me to make videos over in the future, something you need help on, leave a comment down below. I'm very open. I'm a licensed math teacher in the state of Indiana, so you know this information is reputable. If I do make a mistake ever, point it out. That's okay. We all make mistakes. We're all rock stars, not robots. We can make mistakes and correct them, and it's okay. I'm here to help you. So, any topic that you think you might need help on, any specific chapter of a course you're on, whatever, right? I can teach from middle school up to high school, senior level math. So I can have you covered through all of that. So leave a comment down below, subscribe, like, do all the things, and I'll see you next time. Goodbye.